Welcome to section 1.6. This is the sixth session of the ISACA CISA exam prep series. In this session, we'll cover audit testing and sampling. We'll answer several questions. What's the difference between compliance and substantive testing? Why do we sample at all? What's the difference between statistical and judgmental sampling? And what kinds of sampling models exist? Why does this matter beyond the exam? Because you can rarely test everything. Imagine a payment processor with millions of transactions. You can't inspect every one by hand. Sampling lets you draw a sound conclusion from a slice. Choose the right method, and your conclusion holds up. Choose poorly, and you may miss a real problem. So what are the two purposes of testing? The first is compliance testing. It evaluates whether controls are operating effectively. The second is substantive testing. It checks the integrity of actual transactions and data. Let's make the difference sharp. What does a compliance test do? It checks whether controls follow management's policies. Say you worry about a program library control. You might sample programs to confirm the versions match. It tests that a defined process truly exists and works. What does a substantive test do? It confirms the integrity of the actual processing. It verifies the validity of balances and the transactions behind them. You might recheck a complex interest calculation, or confirm a report's data is complete and accurate. How do the two tests relate? There's a direct correlation between them. Strong controls mean less substantive testing is needed. If compliance tests show controls work well, you can do less. But weak controls raise doubt about the numbers. Then substantive testing helps put that doubt to rest. And if early review shows controls are unreliable, lean substantive from the start. So why do we sample? Because time and cost rule out checking everything. The full group of items is the population. The subset you actually test is the sample. You use the sample to infer traits of the whole. What are the two broad approaches? The first is statistical sampling. It uses the math of probability. It calculates the size, selects the items, and evaluates results. Its results are mathematically quantifiable. For it to be statistical, every item needs an equal chance of selection. The second is non-statistical sampling. People often call it judgmental sampling. Here, you use judgment to set the method and the size. You pick the items that seem most material and most risky. When you need a conclusion about the whole population, go statistical. Let's learn the key sampling terms. What is the confidence coefficient? It's the probability that your sample truly mirrors the population. It's stated as a percentage, like 95%. A higher coefficient means a larger sample. If controls are strong, you can lower it. What is the level of risk? It's 100% minus the confidence coefficient. So 95% confidence means 5% risk. What is precision? It's the acceptable gap between sample and population. A wider precision means a smaller sample, but more risk. A tighter precision means a bigger sample. What is the expected error rate? It's your estimate of how many errors might exist. A higher expected rate means a larger sample. A couple more terms round it out. The sample mean is the average across the sampled values. The standard deviation measures how spread out the values are. The tolerable error rate is the most error you can accept, before an account counts as materially misstated. What is attribute sampling? It's used mostly in compliance testing. It deals with whether an attribute is present or absent. It answers the question, how many? There are three related models. Plain attribute sampling estimates the rate an attribute occurs. Think of sign-off approvals on a system access form. Stop or go sampling prevents excessive testing. It lets you stop early when you expect very few errors. Discovery sampling hunts for fraud or irregularities. If the sample is clean, you assume no fraud exists. But a single error flags the whole sample as suspect. What is variable sampling? It's used mostly in substantive testing. It estimates a monetary value or another measurable amount. It deals with characteristics that vary, like dollar values. It tells you about deviations from the norm. There are 3 models here too. Stratified mean per unit splits the population into groups. It samples each group to shrink the overall sample size. Unstratified mean per unit takes one sample mean, then projects that mean into a total estimate. Difference estimation weighs audited values against book values. It estimates the total difference between them. How do you actually build a sample? Follow 4 steps in order. First, determine the objective of the test. Second, define the population precisely. Third, select the sample. Fourth, evaluate the results. What is sampling risk? It's the chance your sample conclusion differs from the truth being what you'd find if you tested everything. There are 2 types. The first is the risk of incorrect acceptance. You judge a weakness unlikely when the population is misstated. The second is the risk of incorrect rejection. You judge a weakness likely when the population is actually fine. Both are why sample design matters so much. So let's bring it together. Compliance testing checks controls. Substantive testing checks the numbers. Strong controls cut the substantive work you need. Statistical sampling uses probability. Judgmental sampling uses your judgment. Attribute sampling counts presence. Variable sampling measures value. And sampling risk runs in 2 directions. Master these, and your sample will always carry your conclusion. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.